Hey, I'm Andrei, and we will spend 30 minutes together to talk about vulnerabilities and how to find them with open source tools. To provide you a bit of context, I was on this DefCamp stage the previous year, and I was presenting at that moment open source, an open core startup that I have with a bunch of colleagues and friends, namely Mutable Security. We wanted to automate cybersecurity solutions, and it successfully failed. After this, I decided for myself that I want to step out of the position that I had at that specific moment, namely cybersecurity engineer in the Romanian army. And this is the last day that I had in the army in the observer's room with a retire sticker on my head. Fortunately, after deciding this, I entered this awesome team, namely the Ubuntu security team. We are helping the Ubuntu operating system to get maintenance, to get certified, and to embed cybersecurity technologies, for example, AppArmor. In the same time, we have this awesome community project, namely Ubuntu Security Podcast, which is led by my colleague, Alex Murray, and he was kind enough to let me present some cybersecurity academic studies in the podcast so you can hear me during these episodes. But I'm here to talk about another topic, namely vulnerabilities and open source. And the reason that I like open source is it's like an open book. You can see the implementation, you can see what the computer should run because you have basically the definition of the application. And I want to start this presentation with an example for Roundcube, which is an open source browser-based IMAP client. It's currently hosted on GitHub, and it has a lot of stars on GitHub. So it is a proof that this software is used a lot in practice. And it's written in a lot of web technologies, and PHP is the most important for us here. So let's look at a specific flow in Roundcube. And we see here that we have a certain route in the application, which is the installer one. It is used, for example, by the administrators after installing the Roundcube instance for setting the configuration. The user control configuration is stored in the raw format in the Roundcube config. And another step in this workflow that I want to present is the following. A person sends you an email that contains an image with a non-standard image. And what Roundcube will try to do is to convert the image into JPEG. For example, if you send a TIFF, that TIFF will be automatically converted into JPEG. And for this, Roundcube leverage a method, namely Roundcube exec, that will execute the output of a function, namely getCommand. And this is the getCommand function. And what you can see here is a sequence of multiple checks, and the third one is of interest for us, namely Roundcube will check that the configuration which is pushed by the administrator is a valid file in the operating system. So my question here is, what is missing? And the answer is input sanitization. The attacker can send a pause request to the installer. And the relevant part here is the IAmConvertPath parameter over there, which contains a PHP reverse shell. After this, the attacker will send an email with a non-standard image. The Roundcube will try to convert the image into JPEG, and the command stored in IAmConvertPath will be executed. So the attacker will have a reverse shell. This is now a CV 2020-12641. It contains a lot of configuration items, such as the one that I already presented, and it leads to arbitrary code execution. It has a high CVSS, namely 9.8, which categorizes this vulnerability as a critical, and it has an APSS of 7.6, which is really high, and it was used in practice by attackers, namely APT28, to compromise some servers of the Ukrainian organizations, and it was added by the American CISA to the known exploited vulnerabilities catalog. And the question after this short presentation of the vulnerability is, was this preventable? And the answer here is yes, but not with standard linters or scanners, because they don't really know of the existence of that rumcube exec function that will execute the arbitrary command which is sent by the attacker. So we can use another technique, which is taint analysis, by setting the roundcube config as a tainted data source and roundcube exec as a sensitive data sink, namely something that may have a security impact to our application if it's used wrongly. Based on this, I proposed in Ubuntu Summit, which was a conference 2 weeks ago regarding Ubuntu, Linux, and open source in general, the open source fortress. This is the link on which you can access the workshop, but the main idea is that I wanted to demonstrate that we can scan our code bases using open source tools. You can only download them, and in 2 minutes to have some results, some vulnerabilities that you can patch before you deploy the code in production. The structure of this workshop is the following. We have some factual information about general software and software security topics, and a brief presentation for each analysis technique, and some practical examples with infrastructure and access, documentations, and proposed solutions. We will cover in this talk, due to time constraints, only the bold parts. Yeah, this diagram will not show maybe for the people behind, but the idea is that we have, as an initial step in discovering vulnerabilities, threat modeling. This process will create a threat model that can be used after that to vulnerability detection approaches, namely manual vulnerability detection and automatic one. The automatic part have a lot of tools that can be run. Their results are aggregated into, for example, the Sarif format. These results are after that triaged and validated in order to find some vulnerabilities. And depending on which side of security you are, you can take two approaches. Either to be a defensive person and to do some vulnerability research, for example, CVSS approximation, CWE approximation, and CV request from a qualified organization, and after that patching and communication with stakeholders. If you are on the offensive side, you have an exploit writing process in which you should detect which is the attack vector, and you should bypass the mitigations that you have. And in the end, you can weaponize your exploit using Dread or Strides or any attack framework that you can have. In this workshop that I mentioned before, I developed an open source Goat-like application, namely Ubuntu Portrait. If you know about the then vulnerable web app or Cloud Goat or anything similar to this, it's a vulnerable application which is it's an application which is vulnerable by default, by design. It is meant to be a lightweight piece of software that runs on an Ubuntu server and allows users to control it through their browsers. And you may guess from this description that something may go wrong. It should be deployed on premise, so anyone who wants to use this software should deploy this on the server, not really using it by cloud. And it's written in Python and C. And this is relevant because of the technologies that I will present. And it embeds 12 plus vulnerabilities, and there is a plus there because the application has a lot of dependencies, and in the meantime, there may be another vulnerabilities that are not registered in the workshop. This is a small demo of the application. You can see that there is a login page that uses the PAM credentials of the Linux operating system. After a successful login, someone can upload some archives, and you can see there a success message. And after that, there are some comments which are in an allowed list. and I can execute them in order to see the content of the archive that I uploaded. And this is the architecture of the application. We have a web UI that connects to a web API, which connects then to a recovery token module, which is built in C. And here we have the PAM that I mentioned before. And the first vulnerability technique that I already mentioned, or not really a technique, but a prerequisite, something that will help your vulnerability detection process, is threat modeling. Namely, we need to think about the assets that we have, namely this food in the fridge, and the threats that may appear, namely this hungry cat. So the questions here are the following: what we should defend, namely the assets, and what can go wrong, namely the threats, the attackers that may attack our application. It should be noted, beside the default advantages like secure by design and stakeholder confidence boosting, that this is a legal requirement in some countries. For example, if you want to have a contract with the USA or Singapore, you need to do a threat model before having that contract. Here I have a demo for the first open source application for threat modeling, namely OWASP Threat Dragon. In the first part, I only imported an existing threat model. And after loading it, I can see that I have a stride diagram over here. And if I click into it, I can see the architectural components, namely the ones which were listed in the architectural diagram before. And we have on top a trust boundary and all connections that may happen between the architectural components. For example, between the web UI and the web API, we can have a login. So the links here, which are in red, depicts some links which may be prone to attacks. And if I continue with the video, I can see the properties of that link into the bottom left part. And on the right, I can see all the threads which are registered for that link. And if I click a link, then I can see the properties of that thread. So as already mentioned, OWASP Threat Dragon is a threat modeling tool. It's backed by OWASP. And the usual process is the following. You need to create a threat model. You need to create a diagram inside the model using a framework such as Stride or CIA. You need to represent the assets in the diagram and to manually identify the threats. There are some commercial tool that does this automatically. For example, if you place to AWS resources, it will automatically list the threats that may appear. But yeah, for this open source software, you don't have this functionality. Following this, we can jump into the next vulnerability detection technique. And maybe you remember this scene from Matrix. We need to talk about code querying. And this means that we have a specific pattern which may be vulnerable, and we need to search it into our code bases. We have an optional representation of the code base into something abstract, for example, abstract syntax tree or code flow graphs. And there are multiple types of query depending on the maturity of the open source solution or the commercial solution. Namely, literals, we can have the string scanf. We can have regexes, namely scanf and something between parentheses, and data structures. And this is something specific to Journ's CPGQL, namely the query language which is implemented for this open source tool for code querying. And what's nice about this technique is that you have community queries. Namely, you can leverage some vulnerabilities which are described by other community members without you writing the rules by yourself. But they are extensive enough to let you write the rules which are specific for your application. For example, the round-cube exec function that I mentioned in the beginning of this talk. This is what a code query engine will understand, namely an AST tree with all the statements defined. And the tool that I want to mention, which is kind of open source, is samgrep. It can be installed very quickly with pip install samgrep. After that, you should leverage the rules which are already defined by the community, or this is an example of a rule written from zero, from scratch. And here I have some logging modules, some methods that can be called, for example, logger.info, let's say, and that has a specific message. And in this rule, I try to detect the passwords and the tokens which are logged. So I'm writing here a pattern, a meta pattern, in which I'm specifying password and token. I'm using this command in combination to the rule already mentioned, namely samgrep scan with --sarif for specifying that the report should be in the sarif format, --config to specify where I stored the rule, --output for specifying where should the tool store the report, and after that the location of the code base. And in this way we have multiple results, and let's see one of them, namely this one. You can see a logging.info, and here I have password, namely a string that I matched into my rule before. So talking about samgrep is a partially open source code scanner. It's basically a startup with an open core model, namely having something in open source but creating a wrapper around that open source tool. It supports a lot of languages, and another fun fact about this tool is that there is no prior build requirement. So for example, if you used Coverity in the past, there is a requirement to build your C code base, for example, before applying the rules, which does not apply in the case for samgrep because it will analyze only the code. And another nice thing about samgrep is that it doesn't have a DSL, a domain-specific language. You can write your rules directly in the language in which the application is written. And you can have default and third-party rules, as previously mentioned. Maybe you remember this scene from Idiocracy, 2006 movie. And here, the computers may have a similar behavior, namely throwing random input to programs. And we need to mention fuzzing. And what this means, we throw random inputs to a program, and we expect it to crash or to behave in an irregular way. And here a crash is equivalent to a security issue. We can have, for example, a null pointer dereferencing, which will cause our application to have some confidentiality damage. Or we can set some sanitizer, for example, address sanitizer, undefined behavior sanitizers, and so on. A disadvantage for this approach is that we have only a BFS traversal in the control flow graph. Namely, it will not go in depth by default. Think about a tree in which for each node you have a check. You firstly need somehow to generate by fuzzing an input that will make that condition to pass, and after that to go in depth. And there may be some optimization, for example, something that AFL++ does, namely a persistent mode in which you are snapshotting the process, and after executing the program, you go back to the snapshot. This is a generic architecture for a fuzzer. And the open source tool that I want to mention is AFL++. It's only a Docker exec that you need to run in order to have this tool set up. And the not quite fun part of fuzzing is that you need to write some glue code between your code base and the fuzzer. It's called a harness, and you can see here that I'm defining a file that is given by argument. And after that, I'm calling the function which is of interest for me, namely generate recovery token with some information which is stored in the file which is generated by the fuzzer. After that, I need to compile that harness using AFLCC. I specify -G for including the debugging symbols. I specify -O for the name of the executable that is created and the files, the source files. And after that, I can start the fuzzing session with AFL fuzz. I specify -I for the dummy inputs. So some inputs that are treated correctly by the application, -O for specifying where the reports should be stored, -- and after that the command, namely the executable, and && for specifying where the name of the file should be placed. This is the nice interface that AFL++ provides. And if I deep dive into a warning which is generated by FL++ for the vulnerable code base that I mentioned before, namely Ubuntu Portrait, I can see here that I have a heap buffer overflow. So AFL++, it's only a fork for AFL, which was developed internally by Google. It has additional features compared to AFL, namely camo emulation, persistent mode, and other optimizations. And it's embedded in Google open source fuzz. So if you have an internet critical project, which is open source at the moment, you can submit your code to Google and it will be fuzzed in their servers with their resources. So I grew up in a small village during summers, and there was this habit to place the keys under the mat and only closing the gate. And I really think that this is applied for security as well, or development as well, because we store our secrets in plain text. And this is where I want to introduce secret scanning. We can think about multiple secrets which can be embedded in our code bases, namely API keys, credentials, tokens, and this technique, namely secret scanning, will scan for a specific pattern and entropy in the code base. There are also some community rules. For example, if you want to find an AWS token, it will surely be a community rule written for this. But if you implement some custom logic for some custom tokens in your application, you should write the rules by yourself. And the open source tool that you can use here is Gitlix. You only download the binary from GitHub releases. You run this command, namely, hey Gitlix, don't specify me the banner, detect all the secrets which are embedded in the code, generate me the report in the Sarif format, consider this code base, which is specified by -- source, store me the report into that specific path, and after that redact me the secrets. Namely, when generating the warnings, don't place me the secrets in plain text, but replace them with a redacted string, for example. After running that command for Ubuntu Portrait, I can see that I find 5 secrets which are embedded, and this is one of them, namely a hard-coded secret key for Flask. And yeah, this is not what you should do for your Flask application. You should generate it dynamically when running the application or letting the user specify the secret, for example, via an environment variable. So, as already specified, Gitlix is an open source detector for hard-coded secrets. What's nice is that it will not scan only the state of the code base as in present, but it will analyze all the Git history. So it will traverse all the Git history that you have in the repository, and it will scan for secrets. And it supports baselines and the custom formats that I mentioned before. And what's nice about baselining is that you can run the detection once. You can see what are the false positives or the false positives. And after that, to mark them as reviewed. So the next run will not show these warnings. Maybe you have watched the Maze Runner. Uh, Basically, they need to run into a labyrinth, and what they've done is creating a map of the labyrinth by running into each street that is there. And we are doing the same with computers with something called symbolic execution in the context of taint analysis. We need to investigate all the paths in a control flow graph by replacing the concrete values, for example, a string, a fixed string, with a symbolic value. Here are multiple components. We can have sources, namely some sources on which an attacker can inject some data. We have sinks, namely some functions which are sensitive security-wise, and some patterns. So a link between the sources and the sinks. This technique will have a problem, namely path explosion. Think about the fact that all the paths which are explored by the engine for symbolic execution are stored in memory. So if you have a large code base that should be analyzed, then that memory will increase a lot. So you may end up filling all memory of your server, for example, with this information related to the paths. Here is an example for a C short program, and on right you can see the representation of that code. Namely, for each node you can see that there is a condition, and the program will try to match these conditions. For example, x minus y should be 0. After that, I want to present CLI, which is a symbolic execution engine. Yeah, as in the case for FL++, you can only run the Docker image. You should also write some glue code in which I will only specify the buffer, namely the re1, and the count, namely the length of the buffer. I'm marking this information as symbolic, and I'm calling the function generate recovery token, but not with some concrete values, but with variables which are already marked as symbolic. This is the clang command that will generate the LLVM bytecode, and after having this, you can only run CLI with the bytecode which is generated. And in this way, I can have multiple warnings for my C code base. And I can see here that the string copy that was mentioned before in the fuzzing section, is also discovered for symbolic execution. So CLI, in fact, is built by a Romanian fellow, namely Cristian Cadar. It's a professor in United Kingdom. So thanks a lot for doing this open source work. It's a generic symbolic execution, but it has a lot of security use cases, and it's built on top of LLVM. Yeah, I will surrender. So I will skip to the conclusions. There are other vulnerability detection techniques that you can see in the workshop, namely ossfortress.io. For example, dependency scanning. But other techniques that I want to mention is stress testing or load testing with JMeter or K6 for Kubernetes, and web dynamic analysis, for example, with WASP-ZAP. We like automation, so this is a quick section for automating the security work. Firstly, all security scanners nowadays will export the results into Sarif. It's a format provided by Microsoft, and you have this library, namely Sarif Multitool, for performing operations with the results that your tooling will provide. For example, merging, paging, querying, suppressing, etc. We have Make and Poet the Poet for running tasks, IDE workflows, namely running the tooling while coding, for example, Visual Studio Code tasks, pre-commits for running some commands before pushing some code into your repos, Act and GitLab runners for executing CI/CD workflows locally, and GitHub Actions or GitLab pipelines for running remote CI/CD workflows. I want to conclude this talk by mentioning Ubuntu, and not really the operating system that we built in in Canonical, but the African philosophy of Ubuntu. What it means is that if I can help you somehow, you'll improve your life. So I will end up having a better life because the society will be better. And there is a quote from Nelson Mandela from 2006 that says that Ubuntu does not mean that people should not address themselves. The question, therefore, is, are you going to do so in order to enable the community around you to be able to improve? What I want to say with this Ubuntu philosophy is that we, security professionals, can do something for the community, and I want to provide a quick list of tasks that we can do. There are a lot of open source maintainers which have this button on their GitHub profile, namely sponsor. You can click it. It means a lot for a maintainer. You can do a security review for an open source project. And it's nice that GitHub already provides this kind of reporting already embedded. And you can develop new security features for some security tooling that is available in the wild. So the conclusion here is the next time you will find a nice bug that you report in a bug bounty program, or the next time you will have success with a corporate project that you develop that is leveraging an open source tool, don't forget to share a glass of champagne with the community. Thanks.
That was such an awesome way to round up your presentation. We have time for one question, I'm afraid. So just one. Just one. Who's the quickest? Do you feel overwhelmed a bit by the huge tool stack? That's okay. It's not a bad thing. So just one question. If not, remember, hats. Oh, there we have one. Please keep your hand up. If you could stand up so my colleague can see you.
Thank you, Andrei, for all the resources. If someone is new and just starting, where's the best place for them to start? If they're limited on time and resources, what would you recommend they start looking at? I know it depends on their code and infrastructure and everything, but what would you recommend?
So what I will recommend is start by doing a threat model for your application, namely to think about what you try to defend and what are the possible attackers that you can have. And after that, just set up these tools that I mentioned, namely a linter, maybe a fuzzer if you have a C code base. Maybe you can scan for secrets and for the dependencies that you have. So the conclusion that I wanted for you to draw from this presentation is that we have some low-hanging tools from the open source space that you can implement in 5 minutes for your code bases.
Thank you.